The feeble energy that sets the air molecules aflutter goes a long way in kindling our neurons, setting our imagination aflame, and stirring our hearts and minds. A sound designer has to harness this energy for the desired effect. We all have experienced pitch darkness sometime or the other. But can you recall really experiencing pen drop silence? The deafening sound of silence, so to say?
Silence is very important এবং সাইলেন্স না হলে কিন্তু আমরা কখনো আসল শব্দটাকে অনুভব করতে পারবো না। ইট ইজ নট পসিবল ফর আস টু ফিল দ্যাট মিউজিক। এবং আমার যেটা মনে হচ্ছে আসল মিউজিক হচ্ছে সাইলেন্স। যেটা জন কেজ কিন্তু খুব ভালো করে বলেছিলেন যে যে দ্য মিউজিক ইনফ্যাক্ট ওনার যখন পারফরমেন্স হতো ওনার একটা কম্পোজিশনে রেখেছিল যে কিছু দুটো লাইন হলো, তারপরে ইট ওয়াজ জাস্ট সাইলেন্ট। অ্যান্ড আমি আই ওয়াজ ভেরি লাকি টু বি ইনটু দ্যাট কনসার্ট, অ্যান্ড ইউ নো ভেরি সারপ্রাইজিংলি উই ওয়ার ওয়েটিং দ্যাট এবারে কি হবে। সো it was 5 minutes silence, and then after that audience wait করছিল যে কি হবে। সো একটা আওয়াজ হতে আরম্ভ করলো এবং সবাই ব্যস্ত হয়ে যেতে পারলো। সো কেউ হয়তো একটু কাগজ নিয়ে ঘষছে বা তারপরে আলটিমেটলি উনি বললেন যে যে শব্দটা আমি তোমাদের কাছ থেকে পেলাম সেটাই কিন্তু মিউজিক।
Any pressure level, difference in pressure level which is below 0.3029 per square centimeter is technically a silence, but I have not seen any place which is having a sound pressure level or difference in the pressure level which is below 0.3029 per square centimeter or 0 dB SPL, because normally the sound studios are the ideally they should be the silent place, most silent place, but in the sound studios also we see the we hear the AC noise or the duct noise, we hear the sound which is being generated by the fan of the machines or the sound which is being generated by the human body itself. So, because of these sources or the sound sources, I believe that absolute silence is not possible to be achieved.
Well, you are probably wondering what I am doing sitting in a toilet playing a guitar. Well, you see, Paul Simon in 1965, he wrote The Sound of Silence sitting in his toilet. You know, it kind of suited him. It was small, comfortable, and it had an echo effect, much like this one. Hello darkness, my old friend, I've come to talk to you again, because a vision softly creeping left its seat while I was sleeping, and the vision that was planted in my brain still remains within the sound of silence. Well, Paul Simon, when he said sound of silence, the silence he was talking about was a societal view of a lack of communication. Now, if you'll excuse me.
Sound has a tendency to proliferate, to find its passage through the tiniest of crevices and round the most formidable of obstacles. That is why it is wiser to put your ear instead of your eye to the keyhole.
Left its seat while I was sleeping, and the vision.
That is why birds and bees are so assured that their mating calls will be heard by their partners wherever they are. And that is why it is so difficult to construct a sound studio that is completely soundproof.
If a machine which is making a shrilling sound can be audible from inside the studio also. So, those sounds basically needs to be absorbed, and we make the absorption with the help of glass wool or some other absorbent material which is put between two walls.
Let us now examine systematically how sound travels. When unhindered, sound travels in straight lines. The path of sound is shown along the radii of these concentric circles. But if there is a big obstacle in its path, the passage of sound will be obstructed. It will be partly absorbed and partly reflected back.
A reflection property. Sound wave can be reflected. That means it obeys the laws of reflection, just like light.
This simple experimental setup can demonstrate the law of reflection followed by the sound waves. The candle gets blown out only when it is in line with the reflected ray of sound. If you measure the angle of reflection, it will always be in line with the angle of incidence.
Most striking example that sound obeys the reflection phenomenon is provided by formation of echo. Echo formation is a natural phenomenon, and it exhibits very clearly, very simply, it exhibits that sound exhibits the phenomenon of a reflection. For recognizing or hearing the echo, certain restriction is there. Restriction about the position of the reflector. Now you see that just like vision has certain restriction, hearing has also certain restriction. And that restriction is in the form of persistence of hearing. There is a term called persistence of hearing. And for a normal human being, the persistence of hearing is 1/10 of a second. So what I mean is that if two sounds are coming to our ear within this interval of 1/10 of a second, you cannot recognize them as separate.
Presuming that the reflecting surface here is 170 meters away, sound has to travel 340 meters before coming back to the boy. The echo is heard exactly 1 second after the original sound. For an echo to be heard distinctly, reflecting surfaces have to be at least 17 meters away from the source.
Come join it, come on. I once was lost, but now I'm found. 'Twas blind
sound gets reflected from all the surfaces around us. When the reflecting surfaces are not so far away, the reflected sound merges with the original sound, making it louder, rounder, richer. These multiple reflections are called reverberations. Reverberations are prominent in cathedrals and big halls.
You must not show to the Secretary of Defense. He knows too much. He knows nothing. He's too busy trying to sell his guns to the
This
president
is another
No,
application of
no.
multiple reflections.
He knows too much.
Something
He knows
spoken
the
in
truth.
whispers at
We
one
must
end
dispose
of
of
this
him.
long winding
Dispose
tube
of him. He's not
is
a milk
carried
carton, you
all
know.
the way to the
He's not
other
so
end.
easy. And what can we do? Well, you see,
The sound
man.
waves get reflected
man.
and
He
re-reflected
might know
along
man.
the walls of
Wait
the
a minute.
tube
do you know
and
this man or
reach
not?
the other end
What's wrong?
almost
Serious.
undamped.
What do we do about this problem? Can we fix
Due
it?
to the strong reflecting nature
Yes,
of the
can.
walls of the tube,
We can't
losses
let it
are
out.
minimal
Never.
in spite of multiple
Never.
reflections.
Never. You must not show to the Secretary of Defense. He knows too much. He knows nothing. He's too busy trying to sell his guns to the president of... No. He knows.
The Imambara in Lucknow is famous for its whispering passages. Tourist guides demonstrate this phenomenon by striking a match at one end of the labyrinthine passage. Someone standing at the remote end of the passage can hear the sound clearly.
We must not show it to him. We cannot show it to the
In
Secretary.
ancient castles in
He
Europe,
knows too much.
spies used
He
to
knows
eavesdrop
nothing.
into conversations
He's too
of
busy trying to sell his
conspirators
guns to the
through
president
these
of-
whispering
No.
tubes.
He knows too much. He knows too much. He knows nothing. He's too busy trying to sell his guns to the president of... No. He knows too much. And he knows the truth. We must dispose of him. Dispose of him? He's not a milk carton. It's not so easy. So what can we do? Well, I know a man who knows a man who might know a
Such
man.
are
Wait
the
a minute.
intriguing manifestations of reflection
What's wrong with
properties of sound.
I have a serious problem here.
What
do we
about the
do about it?
refraction properties?
Can you fix this problem? All the people in love! The relevant party is brilliant! Well, Alex has lost his cell phone in the crowd. Any finders, let us know right here.
Refraction is the property of bending of sound from its straight line path when it enters another medium.
Very simple, striking example of a refraction being satisfied by sound wave is in terms of atmospheric refraction. Atmospheric refraction, a very interesting fact. I can cite before you. One interesting fact is, it is our experience that during the night, if we are on a boat, say moving on a boat in on a lake or river, then over a large distance we can hear the sound of a transistor.
At night, by the seaside or poolside, the air just above the water body is the coolest. As the sound waves travel up, they encounter increasingly warmer layers of air. As a result, they gradually bend outwards. At one point, there is total internal reflection. The waves come right back to the water surface, During the day, the layers above are cooler than the air at the water level. The waves that go up bend more and more inwards and are lost to us forever. So, sound waves keep traveling forward till they encounter a big obstacle and get reflected from it, or encounter a change in medium and bend from their original path. If the passage of sound were that simple and predictable, how is it that in our everyday experience we get to hear sounds whose sources elude us completely? We are entertained by the song of the cuckoo, but it'll take great effort to spot the singing cuckoo hiding behind the leaves. We all have heard the chirping of a cricket, but how many of us know what a cricket looks like? This all-pervading proliferation of sound is made possible by a phenomenon called diffraction. Because of this property of diffraction, we can hear voices even when we cannot see the persons.
To be in a Bengal, come and you will see. Well, to be in a Bengal, the land of mystery. I said, oh, to be in a Bengal, come and you will see. Oh, to be in a Bengal, in the land of mystery.
Sound bends round most obstacles it encounters in its path. If the obstacle is too small compared to the wavelength of sound, the wave simply ignores it. If the size of the obstacle is comparable to the wavelength, the sound bends round the corners, so the shadow behind these obstacles gets shortened. Let us do a simple calculation. Wavelength for a frequency of 10,000 Hertz is 0.034 meters, that is 3.4 centimeters. Wavelength for a frequency of 1,000 Hertz is 0.34 meters, that is 34 centimeters. Wavelength for a frequency of 100 Hertz is 340 centimeters, or 3.4 meters. Wavelength for 10 Hertz is 34 meters. So, gross objects of everyday use will diffract sounds ranging from 1000 Hertz to 100 Hertz. But the same objects will block very high frequency sounds of 10,000 Hertz and beyond. On the other hand, very low frequency sounds will ignore most obstacles and pass round them. These wire meshes are just the right size for creating diffraction patterns for 10,000 Hertz.
About 4 inches.
Every piece of furniture in the sound studio, every accessory used by the sound recordist sets up a diffraction pattern around itself, creating a complex design of sound waves in the confined space. The student of sound has to be sensitive to this invisible design. Here's a quiz for you. See if you can answer it. It's like this. How can the papa elephant hear the sound signals given out by the mama elephant and the baby elephant across the big hill? And the answer is, very low frequency waves manage to bend around the hill and reach the papa elephant.
We will end this episode with that interesting bit of information. But before we close down, a quick recap. The natural path of sound is a straight line. When it encounters a change in medium, it bends from its original path. This phenomenon is called refraction. When it encounters a big obstacle, like a cliff or a wall, it is reflected, obeying the laws of reflection. When the obstacle is comparable to the wavelength of sound, it bends round the obstacle. That is why, even though the cuckoo eludes us, its call finds its way through the openings between leaves and branches, bends round the trunks of big trees, and reaches our ears. The chirping of a cricket fans out from its burrow and permeates the entire space. Sound finds its way through the slightest crack in the wall and spoils the soundproof environment of the studio. Reflections, refractions, and diffractions form a complex sound pattern around us. We live in a sound environment.
No woman, no cry.
No woman.
Well, Alex has lost his cell phone in the crowd. Any finders, let us know right here. Chop, 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 come on. To the beat, everybody on the board, you gotta stop the trumpet.